New features took 40% longer than estimated. The root cause? No abstraction layer between Shadcn primitives and your app. Let's break down reusable component library Shadcn UI, how it works, and the exact mistake behind that failure. Shadcn/UI is not a traditional NPM package. It's a collection of copy-paste-ready React components built on Radix UI primitives. You run a CLI command that copies source code into your project, giving you full control over customization. Without shared wrappers, every component instance duplicates logic. Shared wrappers centralize common logic like loading states, tooltips, and analytics into a single component, reducing re-render overhead and bundle size. A production-grade library requires 3 distinct layers. Layer 1 is the raw Shadcn primitive. Layer 2 is your design system wrapper that applies design tokens and enforces accessibility. Layer 3 is feature components built from Layer 2 wrappers. The wrapper maps your team's intent-based naming to Shadcn's internal variant system. It also adds loading state with proper ARIA attributes and omits Shadcn's internal props so consumers never need to know them. Here's the wrapper code. We define variant mappings from our intent API to Shadcn's internal variant and size props. This way, application code never needs to know Shadcn's naming. The component uses the mappings and adds loading state with a spinner. It also sets ARIA attributes for accessibility. Note that we omit Shadcn's variant and size props to enforce our own API. Most teams already have scattered Shadcn imports. Here's an incremental migration path. First, audit all direct imports, then create the UI package, migrate one feature directory at a time, and finally add ESLint enforcement. Run this script before starting migration to understand the scope. It lists every direct import from the Shadcn components/UI directory, sorted by frequency. Shadcn/UI themes through CSS Variables. This is deliberate. CSS Variables cascade through the DOM tree, enabling per section theming without re-rendering components. Dark mode is just a dark class that redefines variables. Define all tokens in globals, CSS under at layer base. Dark mode and brand overrides are just variable redefinitions. Components reference variables directly, they never receive theme info via props. The Shadcn CLI copies components into your project. In a monorepo, install primitives into a dedicated primitives directory inside the UI package. Never modify primitives directly, treat them as a managed upstream dependency. Configure components, JSON to point to the UI package root. This ensures the CLI installs primitives into the correct location and generates imports that reference the shared package. Your wrapper layer can break accessibility by overriding ARIA attributes. Every wrapper must preserve the accessibility guarantees of the underlying Radix primitive. Add automated tests with JSTAX and manual testing with screen readers. Here are accessibility tests for the button wrapper. We use JSTAX for automated scans and test ARIA attributes like ARIA busy and ARIA disabled. These tests ensure our wrapper doesn't break accessibility. A single change to a wrapper can affect hundreds of feature components. Visual regression tests catch unintended UI changes before they reach production. Set up tests at the wrapper level for every variant. Here's a Playwright visual regression test for the button wrapper. It tests every variant in both light and dark mode, comparing screenshots against a baseline. Run this in CI on every primitive update branch. The most common deployment pattern is an internal monorepo package. For fewer than 5 apps, use source imports. For larger scale, compile with soup and publish ESM as the primary format. The package, JSON exports field maps entry points. Note the sideEffects field. Without it, your globals, CSS will be tree shaken away in production builds. Always mark CSS files as sideEffects. The biggest adoption killer is a prop API that doesn't match how teams build features. Use intent-based naming, provide composition props like left element, and always include a className escape hatch. Here's an input wrapper with composition props. Left element and right element allow adding icons without manual DOM manipulation. The error prop sets ARIA invalid and shows an error message, and we always merge className with CN. This is the same issue we highlighted at the start. Here's exactly why that happened. A team with 50+ button instances across 12 pages had no shared wrapper. Each instance included its own styling and event logic, causing Radix primitives to reinitialize. The result was a 40% slower initial render and a lighthouse score drop from 85 to 62. Each team ran npx Shadcn at latest add button independently, customizing in isolation without a shared wrapper, leading to inconsistent design tokens and accessibility standards. The fix was to create a shared button wrapper that maps intent to Shadcn's variant using intent to Shadcn variant. This centralized common logic reduced re-render overhead and restored performance. The same wrapper also enforced accessibility defaults. If application code imports directly from the primitives directory, your abstraction layer becomes optional. Developers will bypass it, leading to inconsistency and performance issues. A media company's shared Dialog wrapper had broken focus trapping, a single line missing from the Radix composition. Every feature that used Dialog inherited the bug, affecting 14 product surfaces. This is the exact pattern that caused the incident. Each page imports the raw Shadcn button directly, duplicating logic. The fix is to create a shared wrapper and import from there. A team published their UI library without the sideEffects field. Development builds looked correct, but production builds tree-shook globals, CSS away, leaving every component unstyled. It took 6 hours to diagnose. A team's input component did not accept className. A developer needed to adjust margin, so they copied the input and modified it locally. 6 months later, 4 input variants existed across the codebase. The article mentions enforcing import boundaries, but does not show the ESLint configuration. This rule blocks direct imports from the primitives directory, ensuring application code only uses layer 2 wrappers. Shadcn/UI relies on Radix UI primitives, which may have breaking changes between minor versions. As of 2025, Radix UI v1x supports React 18 and 19, but some components, e.g. Dialog, changed portal behavior in v110. Always pin Radix versions in package.json and test after updates. The article describes configuring components, JSON for a monorepo, but does not show a complete example. This configuration ensures the CLI installs primitives into the correct directory and uses the correct aliases. To diagnose missing wrapper issues, start by auditing direct imports with grep. Then check bundle size with SourceMap Explorer to see if components are duplicated. Use React DevTools Profiler to identify unnecessary re-renders. Let's run through some common interview questions. What is Shadcn/UI and how does it differ from traditional libraries? It's a copy-paste system. You own the code. Why do shared wrappers improve performance? They centralize logic, reducing duplicate reinitialization. How do you enforce import boundaries? ESLint no-restricted imports rule and CI checks. And a few frequently asked questions. Should I use Shadcn/UI for a small project? Yes, raw imports are fine for small projects. How do I update Shadcn primitives? Rerun the CLI and use npx Shadcn at latest diff to review changes. What is the sideEffects field for? It prevents bundlers from tree-shaking CSS files. Let's recap the key takeaways. Use 3-layer architecture, primitives, wrappers, features. Always create shared wrappers for repeated components. Theme with CSS variables, not props. Enforce import boundaries with ESLint. Ready to go deeper? Up next, introduction to JavaScript, then variables in JavaScript, then data types in JavaScript, and operators in JavaScript. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.